So I want to have a look at solving harder ratio problems. I'm going to use two techniques to solve this first question here, and you'll see why I use two techniques when we move on to the second question. So first I invite you to have a go at this question without me going through it first. So I'm going to assume you've had a go, you've paused the video, you've had a go. So let's go through this problem using our first method. Let's get this information that is given to us in words down in some symbol form first. So I'm given that the ratio between small and medium plates, so this tells me a relationship between the two. So for every 2 small plates that I have 5 medium plates. And the second ratio here is between medium and large plates. So for every 3 medium plates that I have 4 large plates. Let's think of a scenario where I have a certain number of medium plates. And in this scenario, well, let's see, I'm going to have 15 medium plates. So what is the number of small plates that I have going to be? Well, I have 3 times as many medium plates as in my simple ratio, telling me the relationship between small and medium. So here I'm multiplying by 3. And so, knowing ratios, I'm going to have to multiply the other side by 3 as well. So instead of 2 plates, I will now have 6 plates. So I've worked out the number of small plates that I must have in this situation. Well, what about how many large plates I would have in this situation? Well, I've multiplied the number of medium plates I have, this time by 5. So I have 5 times as many medium plates as my ratio told me. This means that I'm going to have to multiply the number of large plates by 5 as well, which means that I will have 20 large plates. And you can see that I've written these 3 numbers in a ratio form, and this tells me the relationship between all 3. So I could say that the relationship between small plates and large plates was 6 to 20. I could say that the relationship between medium plates to large plates was 15 to 20. And I could say that the relationship between small and medium was 6 to 15. So all of these ratios here can be cancelled down and simplified back into the original form we were given. But only in this situation, where the middle number is 15, can we equate small and large plates in ratio form. So the important thing to note here is that we have gone from 2 numbers for medium, so 2 numbers that tell us how many medium plates we started off with, and note that the medium plates are the items shared by both ratios, and I found the lowest common multiple of those 2 numbers. So I've multiplied each ratio by the number it takes to get that medium plate number to the lowest common multiple. And this side I've multiplied by a different one, as 3 requires a different number to get to 15. So that's the first method of doing it, by finding the lowest common multiple of the shared item. Well, what about if I wanted to find the ratio between small plates and large plates? Well, obviously I could go through this method here, and I could find the ratio between all 3 of them, then take out the ratio between small and large, so 6 to 20, and then simplify it. So between small and large, it'd be 6 to 20, and then divide both sides by 2, gives me 3 to 10. So for every 3 small plates that I have, I must have 10 large plates. But there's another method to do this, and this method involves us being very happy converting between ratios and fractions and what they both mean. So originally I had small to medium, equaling 2 to 5. Another way to write that is small plates divided by medium plates. So this is the number of small plates that I have divided by the number of medium plates that I have, and that simplified down becomes 2 over 5. It becomes that fraction. So I could have 6 small plates and 15 medium plates, and simplified down, that fraction would be 2 over 5, because that's the relationship between these two numbers. And I can rewrite this equation here. I can rewrite that as 5s equals 2m. So on the left-hand side, the number of plates should equal the number of plates on the right-hand side. The same is true for the relationship between the medium plates and the large plates. So that originally was 3 over 4. So 4 times the number of medium plates should equal 3 times the number of large plates. We should have equal numbers of plates on both sides. So what can we do with these two equations? Well, this 2m here happens to be half of this 4m here. So if I times by 2 on both sides, in order to get 4m equals 10s, then I will have the same number of m's in both of these equations. Therefore, I can equate the 10s to the 3l. These must be equal to each other. So 10 times the number of small plates at any time should equal 3 times the number of large plates at any time. So this tells me a relationship between small plates and large plates. And how do I convert this back into a ratio? Well, if I divide both sides by L, I get S divided by L is equal, and then if I divide both sides by 10, I get 3 over 10. So S to L equals 3 to 10. And if we have a look at what we worked out previously, this 6 to 20 simplified down to 3 to 10 as well. So using fractions, we have found another method of combining ratios. So let's have a look at a slightly harder problem now. So let's again write this down in symbol form. We have got white chocolate to not white chocolate is 3 to 4. And we have not dark chocolate to dark chocolate is 17 to 4. So we can write not white as something else. We can write that as the sum of the milk chocolate plus dark chocolate. And over here we can rewrite not dark chocolate as the sum of the white chocolate plus the milk chocolate. And if we use the method from the last question, where we convert these ratios into fractions, well, what can we do with this? So before we cross-multiplied these fractions in order to get everything on the top line. It made it look a bit tidier, and so let's do that. And now you'll spot that I have in here a 4w and a 4w. So let's rearrange this second equation on the right in order to be 4w equals 17d, take away 4m. So now I've got two equations that are equal to 4w. At this stage, we don't need to think about what these mean. We don't need to think about the ratios. We're treating these as equations now. And all we want to do is get rid of one of these symbols in order to find the relationship between the other two. These two right-hand sides must therefore be equal to each other. So 3m plus 3d is equal to 17d minus 4m. Let's simplify those. So if I add 4m to both sides, I have 7m. If I subtract 3d from both sides, then I have 14d on the right. So how do I change this back into a ratio that I can work with? So dividing both sides by d, because remembering that I would like m and d expressed as a single fraction, if we go back to the question before, you can see that s and l is expressed as a fraction with just those letters in it. So I want m and d in a fraction, just those letters, and then divide both sides by 7, I get 2 divided by 1. So the ratio between m and d, or the number of milk chocolate pieces and the number of dark chocolate pieces, the ratio between those two is equal to 2 to 1. So for every 1 piece of dark chocolate, I will have 2 pieces of milk chocolate. Hopefully it makes sense up to there what we've done. And if I give me some, let's get some space back here, let's get rid of that. Okay, so using this newfound relationship between m, the number of milk chocolate pieces, and d, the number of dark chocolate pieces, using that relationship, let's go back and have a look at this first ratio. So on this right-hand side here, we have the sum of the milk chocolate pieces plus the sum of the dark chocolate pieces. And that number there must be divided into 3 portions, as demonstrated by this ratio that I've worked out. So if m plus d is 4, I need to split that 4 3 ways in order to work out how many milk chocolate pieces and how many dark chocolate pieces I'd have, because 2 of those portions are milk chocolate and 1 of those portions is dark chocolate. So if we split that 4 up via this ratio that we worked out, we'll have 4 divided by 3 times 2 and 4 divided by 3 times 1. And if we work those out as fractions, we'll see that we get 3 to 8 over 3 to 4 over 3. So this is a relationship between all 3 of my chocolates now. So as you can see, the split between the milk chocolate pieces and the dark chocolate pieces here, I'll write underneath what this shows us. The ratio between m and d still holds true. That is still a 2 to 1 ratio. If you work that out, if you simplify that, you will find that it's the same as 2 to 1. But obviously, ratios don't come in this form. They come in whole number form, so we're going to have to convert all of these into a whole number. So let's times everything by 3. So we'll have 9 to 8 to 4. And that tells me the relationship between all 3 of the types of chocolate. So whenever you come across questions when there are ratios between sums of things, the best method to use is converting to fractions and working from there.